Qatar's national emblem shows two curved swords crossing each other. Engineers looked at that emblem and decided to build it at full scale, out of concrete and steel, rising 211 meters out of the Persian Gulf. Not two straight towers angled to suggest a crossing. Two towers that actually curve, floor by floor, the entire way up. This is Qatar Towers in Lusail, Qatar. 36 stories of continuously curving concrete, engineered to read as a pair of scimitar swords from any angle you look at it. 8 core walls working together across 5 separate structural zones. A formwork system that had to reinvent itself on nearly every single floor. And a hotel complex built to open in time for the biggest event Qatar has ever hosted. Here's the part that sounds almost unreasonable as a design brief. A straight tower is hard enough to build well. A tower that leans at a fixed angle, like some of the more famous tilted skyscrapers built elsewhere in the world, is harder still. But at least the lean stays constant floor after floor. Qatar Towers doesn't do either of those things. Each tower curves continuously along its height, meaning the angle, the offset, and the shape of the floor plate change at essentially every single level, all the way from the podium to the roof. Lusail itself is the setting for this project, a planned city built from scratch on Qatar's coast, covering roughly 38 square kilometers north of Doha, designed from the ground up with landmark architecture as part of its identity. Qatar Towers sits at the southernmost point of that development, right on the harbor, positioned specifically so the crossed sword silhouette becomes visible from across the water, long before you ever reach the building itself. The design brief comes from Qatar Hospitality, the project's developer, who wants a building whose architecture is instantly recognizable as distinctly Qatari, rather than another generic luxury tower that happens to be built in the Gulf. The chosen reference is the pair of curved swords, sometimes called yataghans, that appear crossed on Qatar's national coat of arms, a symbol with deep roots in the country's history. Architects at Dar al-Handasa, working with Kling Consult on the architecture and HBK contracting on the build, take that two-dimensional emblem and translate it into a three-dimensional pair of towers, curving outward from a shared podium, in a shape that reads simultaneously as crossed swords, a crescent moon, and a horseshoe, depending on the angle you're viewing it from. Structurally, the completed complex is organized into 5 separate zones, supported by 8 individual core walls, with the 2 tallest and most visually dramatic structures, referred to internally as towers, 2 and 4, forming the actual crossed sword silhouette that gives the whole project its identity. Those 2 central towers each cover a footprint of roughly 2,300 square meters at their base and climb 36 stories to a final height of 211 meters. Before any of the dramatic curved concrete can rise, engineers first have to get the core walls right, since those cores carry the primary lateral load for the entire structure. Rather than relying on outriggers or an external bracing system, the way some other unusually shaped towers do, Qatar Towers' design leans almost entirely on the stiffness of its own core walls to resist wind and seismic loading, a decision that keeps the exterior silhouette clean and uninterrupted by visible bracing. But that also means every core wall has to be poured with exceptional precision, since there's no secondary system waiting to compensate if the geometry drifts even slightly out of tolerance. Qatar itself sits in a region of relatively low to moderate seismic risk compared to many other parts of the world, which gives engineers a bit more room to lean on stiffness alone, rather than adding the kind of heavy secondary bracing systems used on towers built in more seismically active zones. But wind loading off the open Gulf still has to be accounted for at every stage of the design, particularly given how much surface area a continuously curving facade presents compared to a flat, conventional tower face. Climbing formwork systems get used to erect those core walls, a family of systems that essentially climbs the building alongside the concrete itself, jacking upward level by level, rather than requiring scaffolding rebuilt from scratch at every floor. Because the towers curve, rather than run straight up. The climbing formwork can't simply repeat an identical cycle floor after floor, the way it would on a conventional high-rise. Each level requires the formwork geometry to be recalculated and reset to match the specific curve and offset called for at that exact height, effectively treating almost every floor as its own unique formwork configuration rather than a straightforward repetition of the floor below it. Coordinating that recalculation without slowing construction to a crawl means the project relies heavily on detailed digital modeling of the entire curved geometry well before crews ever reach a given floor. Engineers work out the exact wall angle, panel configuration, and anchor positions for each level in advance, so that by the time a climbing formwork crew reaches a particular height, the adjustments needed for that specific floor are already fully specified, rather than being worked out on the fly under time pressure with concrete curing on a schedule. That same problem shows up again, in an even more demanding form, once attention shifts from the vertical core walls to the horizontal floor slabs. Because the towers curve outward as they rise, individual floor slabs protrude out past the slab below them by different amounts at nearly every level, creating a continuously changing cantilever condition running up the entire height of both towers. A table-based slab formwork system gets deployed to handle this. Essentially large horizontal platforms that support the wet concrete for an entire floor slab and then get mechanically lifted up to the next level once that slab cures, saving crews from having to strike and rebuild conventional shoring at every single floor. On a conventional tower, these lifting tables could be built once in a single standard size and simply reused floor after floor without modification. On Qatar towers, that approach doesn't work because the slab geometry itself keeps shifting as the towers curve. Engineers instead have roughly 10,000 square meters of these lifting tables manufactured in custom sizes, specifically configured to match the different slab shapes and protrusion distances appearing at different heights up each tower. And the table lifting mechanism itself has to be specially modified to cope with the building's continuously inclined facade, rather than the fixed, repeating geometry these systems are normally designed around. At the base of both towers, additional load-bearing shoring towers get used to support an unusually tall ground floor mezzanine level, standing over 6 meters high, well beyond what a standard floor-to-floor formwork cycle would typically need to span. Keeping that many custom-configured tables moving through the construction schedule without creating bottlenecks becomes its own logistical exercise. Rather than a single crew repeating one familiar sequence hundreds of times, site teams effectively have to manage what amounts to dozens of slightly different construction sequences running in parallel across both towers, each floor requiring its own specific table configuration, its own lifting sequence, and its own quality checks before the next pour can proceed safely above it. Getting that sequencing wrong on a curved tower carries more consequence than it would on a straight one, since an out-of-tolerance slab at one level doesn't just create a cosmetic problem. It can throw off the geometry every floor built above it needs to match for the rest of the tower's height. Every one of those custom slab configurations also has to account for something most conventional towers never have to worry about at all. The building's own silhouette changes continuously as you move up it, which means the mechanical, electrical, and fire protection systems threading through every floor also have to adapt to a constantly shifting envelope, rather than repeating the same layout floor after floor. Fire protection alone becomes its own specialized engineering exercise. The atrium spaces inside the towers get divided into fire safety zones using accordion-style fire curtains designed to drop automatically and seal off a section of the building the instant a fire is detected, preventing flame and smoke from spreading vertically between floors. Because the atrium follows the same curved, elliptical geometry as the rest of the building, engineers can't simply install standard straight-line fire curtains here. Each curtain has to be custom designed and manufactured specifically to conform to an elliptical opening rather than a conventional rectangular one, with different perimeter lengths and heights required at different points around the atrium. all while still meeting the same fire safety certification standards required of any other high-rise in the country. Beyond the structural and fire safety engineering, the building also has to survive daily conditions specific to its location directly on the Gulf Coast. Extreme heat, high humidity, and airborne sand all accelerate wear on exposed concrete, steel, and glazing far faster than they would in a more temperate climate. So every exterior material and every exposed structural connection gets specified with that corrosive coastal environment in mind, aiming for a building that still looks and performs the way it was designed to, decades after the ribbon cutting, rather than showing its age within just a few years of opening. Around the towers themselves, the surrounding podium and landscape get designed with just as much intentionality as the structure rising above it. Landscaped gardens and water features surround the base of the complex, including an arrival water feature specifically designed to evoke the shape and motion of a falcon in flight, a bird with deep cultural significance across the Gulf region. The podium itself is shaped to give the impression that the entire complex is floating directly on the sea, an illusion reinforced by the way the curved towers rise directly out of that base, rather than sitting on an obviously separate ground-level structure. Once complete, the finished complex spans roughly 300,000 square meters of total floor area, served by 67 elevators moving guests and staff between the tower's many different functions. Rather than a single hotel operator running the entire building, Qatar Towers ends up split between two entirely separate five-star luxury brands, with Raffles Doha occupying one tower as an ultra-luxury, all-suite property offering 132 suites, many with private butlers and expansive layouts drawing on both Qatari heritage and contemporary design, while Fairmont Doha occupies the other tower as a five-star property in its own right. Beyond the hotel rooms themselves, the complex also includes a dedicated event space, Qatar Hall, capable of hosting roughly 2,500 guests, alongside restaurants, boutique retail, and additional leisure facilities spread across the podium and lower floors shared by both towers. Construction on the main towers begins in earnest in September of 2018, following years of earlier site preparation, with an original completion target set for May of 2021. The scale of the curved formwork challenge, combined with broader construction and supply pressures affecting major projects across the region during this period, pushes the timeline out further than originally planned. The project ultimately reaches completion in 2022, with both hotels opening to guests in time to serve as part of Qatar's hospitality infrastructure surrounding the 2022 FIFA World Cup, before fully opening to the general public in January of 2023. The total cost of the project lands in the range of $600 million, covering not just the structural and formwork challenges of the twin curved towers themselves, but the extensive interior fit-out required to deliver two separate five-star luxury hotel experiences, the surrounding landscaped podium and water features, and the dedicated event and retail spaces built into the base of the complex. What makes Qatar Towers stand out isn't simply that it looks like crossed swords from a distance. Plenty of buildings around the world commit to a striking silhouette without much structural consequence attached to it. It's that translating a two-dimensional national symbol into an actual 36-story building meant treating nearly every floor as its own unique engineering problem, recalculating core wall geometry, redesigning slab formwork, and custom-fitting fire safety systems level by level, rather than repeating a single solved design over and over the way most tall buildings can. Two curved concrete towers, rising 211 meters out of a podium, built to look like it's floating on the Gulf, standing in for a national emblem that used to exist only as a two-dimensional image on a coat of arms. Compare that approach to how most iconic towers achieve their signature silhouette, and the difference becomes clear. A twisted tower, like several built in other Gulf cities over the past 2 decades, typically rotates a single repeated floor plate around a fixed vertical axis, which means the floor plate itself and the relationship between adjacent levels stays mathematically consistent, even as the building visually spirals upward. A tilted tower, like the record-holding leaning structure built in Abu Dhabi, commits to a single fixed lean angle applied consistently once the base geometry is set, meaning the engineering problem, however extreme, still only has to be solved once and then repeated. Qatar Towers does neither. The curve changes continuously along the height of both structures, meaning there was no single formwork solution, no single slab configuration, and no single fire safety layout that could simply be engineered once at the start of the project and repeated all the way to the roof. That distinction is also why a project like this takes years longer to build than its raw height alone might suggest. 36 stories and 211 meters would be an entirely ordinary construction timeline for a conventional tower of similar scale, built almost anywhere in the world. Here, nearly every one of those 36 floors demanded its own bespoke engineering solution before a single additional meter of height could safely go up above it, turning what looks, from a distance, like an elegant two-tower silhouette into one of the more procedurally complex high-rise construction projects completed anywhere in the Gulf region. If you want to see which megastructure we take apart next, hit subscribe. We're just getting started.